Record. Okay. Hey, everybody. Welcome to Richmond Java User Group. My name is Jeet. I'm your organizer for today. Today's talk, we have Yatin from VMware. He used to work at Pivotal before VMware acquired them. He's got a ton of experience in the industry, and just from my brief conversation with him, seems like a pretty cool guy. And I'm happy to have him give us a presentation on Spring Native. And that's, without further ado, let's, you're welcome to share your screen and take over.
Yeah, hey, thank you for that warm welcome. Let me share my screen. All right, everyone can see the PowerPoint, yes?
Yep.
Cool.
If anyone has any questions, Yatin, how do you want them to ask them? Do you want them to unmute themselves and speak, or to put it in the chat and me talk to you and say, hey, we have questions?
Feel free to interrupt. Again, I want to keep it as conversational as possible. It's a evening call, so I want to keep it as light as possible. Like I said, I'm just excited about this tech, so I want to keep it light, keep it conversational. Feel free to interrupt anytime. I just want to share and chat about this cool new tech that's innovation that is happening in Spring.
Okay.
All right, so cool. Thank you everyone for joining, and again, thank you for this opportunity to speak. I'm Yatin. I'm a platform architect within the Map BU business unit of VMware. Came over from the Pivotal acquisition. Pivotal and now VMware, we are the main sponsors of Spring. And again, there is a lot of innovation happening. Spring is by far the most popular framework in Java ecosystem. So I thought this is pretty cool. So let me get started. Yeah, so I had to put a safe harbor statement. Again, what we are going to learn today is in alpha stage. We are soon expecting beta, but it's all open source. So this, the deal. It's yeah. All right, so like I said, I want to keep it light. Just want to see why, what, and how of native images, right? Make sure there is a lot of pain that the Spring team is going through to make sort of as a developer life much more easier. I just wanted to step back and see what is native images, why are we doing this, and a little bit of how. Again, I'm not an expert on Graal or even the Spring Native, but at high level, I think it's good to understand what's happening. And then we'll talk about trade-offs. Nothing comes for free, right? So let's talk about that, chat about it. And I do have a simple demo. Again, it shows the sort of power of what Spring team is doing. And then we'll wrap it up with a quick roadmap, items, and key takeaways. Does that sound good to everyone? Yeah. All right. So, let's jump right in, right? Like, we talked about Spring. Again, it's awesome. But let's jump into, what are native images, right? If you use Go or any other sort of languages which do not have interpreter or whatnot, you would notice, especially with Docker containers and containers in general, they are very small, right? And they start really fast. So performance from that aspect is really good. And that used to what I hear, right? Like or still do, right? Where Java programs, can take anywhere from 3-4 seconds to 5 seconds, 10 seconds to start up. And in a sort of monolithic world, it's okay, right? Like it doesn't really matter. You start it and you forget it, right? But if you're thinking about microservices or leveraging some of the modern cloud based systems like serverless or lambdas, then you are you have to consider those things, right? Like if you really want to have scale to zero kind of optimizations, then you need to have services that can be spin up and can start really quick. We are talking about milliseconds, right? And scale up and down real fast. And again, that is one of the things that I felt like Java has been sort of falling behind, and that's where sort of native images come in, right? So these are essentially, new type of executable program built from your Java application, right? And then you just run it on the target platform without JVM. So in the image here, you can see traditional stack. You have OS, like hardware OS, and then you have Java virtual machine. You have your Java packages, different packages, and your Java code. That all sort of combines into this native image, right? And I'm saying image here because this is very it's a perfect. It's perfect for Docker containers, right? Or containers in general, right? You can run it, sort of natively on, whatever target platform, Linux, Mac, or I think Windows support is almost there. You can compile it for that and run it, but it just makes sense to run it in a container, right? And that's what the main motivations are, right? Hey, let's build something that is optimized for this cloud native containerized world. So the idea is to basically compile it ahead of time, right? And you have this native image which has benefits of Java that you're familiar with in development, but at the runtime there are benefits for speed and smaller footprint and things like that. So we are going to talk about those. So let's move and see. Yeah. So just to sort of show it in a different graphical format, right? Like the top one is your, traditional flow, right? You have your Java classes, you have your Javac, you compile it into Java bytecode, you archive it in a jar file, right? And then you sort of either give it to your DevOps team or CI/CD system, and it deploys it onto the target platform. Now that one, has a JVM, right? And it has a JIT compilers, and that one turns it into native code or sort of run it for you, right? And that's a pretty well understood format. The key difference is ahead of time compilation here, right? So what you are doing is you are building a native executable as part of your compilation, right? And I'll show you how that happens. There are different ways to do that, but Spring Team has made it very straightforward, right? You don't need to install any dependencies locally, anything like that. There is a Maven goal, and you just hit that one, and it just works, right? It spits out a compliant Docker image, and basically what you get is that image that you can run now, right? Like as executable. So that's essentially what native images are, right? Instead of building your images with JVM, Java runtime, right, and your code, you are building it ahead of time, and that spits out a native executable, right? Again, another graphic here, but you have any JVM language, Java, Kotlin, right? And you have your native compiler. In this case is GraalVM, right? So GraalVM is a project from Oracle, and there are different versions of it, right? There is a native, there is a community edition, there is an enterprise edition. I'm not going to get into the licensing aspect of things, but right now Graal is probably the best option to build these native images, and Spring Team is working closely with the GraalVM team as well. So yeah, I think this is the main thing, right? Like this is what I want you to take away from this session. If there is one thing, why use this? Why go through all of this trouble, right? And there are basically, it comes down to two things, right? Like faster startups and lower memory and footprint and less CPU consumption. Now, when I saw the numbers, I was blown away, right? Like, it's a day and night difference, especially for the smaller Java projects, right? Like again, we are talking about microservices, right? And the again, why we do that, right? Like faster startup, if you're talking about having ability to scale up and down real fast, right? In a Kubernetes world or any, container orchestrator where you want to be, your load is uncertain and you want to leverage this cloud environment much more efficiently, right? So you can scale up and down. And in that case, you want to have ability to, start in milliseconds. And memory is, essentially now you can run these services, these Java programs on a much smaller VMs, right? And what that means is you pay less per hour, per minute, per second in some cases, right? And that's just, that's just good thing, right? You're basically better utilizing the cloud, and that's just, in two things, that's the main reason why we want to use this. A few things, right? Essentially, I mentioned early on, regular JVM startups, you can see anywhere from 4 to 5 seconds to 10 seconds, right? I have even seen further, right? Especially for older Java projects. But in this case, it's milliseconds, right? And the magic happens because you're spending that time somewhere else, right? You're building ahead of time, and I'll come to trade-offs. And again, that is another important thing that you have to think about as a developer, as architects, right? So let me move on to next one. Yeah, so memory again in some cases is up to 4 times less. Think of it like, hey, then your VMs are going to be 4 times cheaper. However, there is a little asterisk there, right? Lighter memory footprint for smaller apps, right? So if you have a monolith, it will still go down, right? It will still be more efficient in using the memory, but it may not be as 4 times smaller, right? In terms of memory footprint. That app runs on RSS memory, I'm talking here. So yeah, again, CPU and memory. A little bit of how, again, like I said, I want to keep it light. And, the key benefit and the key motivation for Spring team to do this is, our goal is for you, as in the Spring developers, they shouldn't have to change anything, right? And that's a tall order. There are a lot of things that happen behind the scene to build these native images. But that's what we want to do, and I think they're fairly close to that, right? Again, I'll show it in a demo. But real quick, right? The GraalVM native image, there is a plugin, right, in a Spring world, right? You can essentially what it does, it analyzes your code, right? And it tries to figure out every possible execution path, right? Ahead of time, right? Unused path and classes are ignored. There are even flags that Spring Team provides that hey, I'm not going to need, YAML parsers or XML things. You can just turn it off and, they will be completely ignored. So things like that, right? So there is that analysis phase. Then you actually build the image, right? You specify the target platform. So again, there is that difference. Java used to be build once, run anywhere on that kind of thing, right? Because JVM will translate it for you. In this case, we are building to target a specific platform. Now, that is not a big issue anymore because of containers, right? And we are going to build it for a container OS, right? And we are going to package it together as a container. So we are not shipping your application archives or jars. We're shipping your container, right? And that's what it is going to run everywhere. So that's not a problem anymore, right? But yeah, you're building this, and then you build the image, and GraalVM plugin will build the image for you. And then, you are off to races. It can run on pretty much any platform that can run containers, Docker containers, or more specifically OCI containers. Kubernetes is, I guess, by far the most popular one, but Cloud Foundry, any of the container orchestrators, you'll be fine with that. Yeah. So, any thoughts so far? Does this seem like exciting stuff, or?
Yeah.
Yeah, it seems. Go ahead. Sorry.
No, you go ahead.
Well, I was just going to say, yeah, all this sounds fantastic and amazing, and I was just going to ask, yeah. So what's the downside, if you will? So I guess you'll get to that shortly. But yeah, that seems really exciting.
I had two questions before you get to it. I don't know if you might talk about it here, but you're talking about well, one was the reduced memory footprint, and I was wondering where that came from. And possibly related, you're talking about how the way the native code compilation goes, it's not using any of that JIT compilation process, which, it's my understanding, I could be wrong, but that JIT compilation process is actually putting the parts of your code you're using most frequently in memory so that it's more quickly accessible. So I was wondering if there's a CPU, like a speed aspect that you lose by doing this native piece.
Yeah, that's a great catch, and yeah, I'm the next slide is going to cover that one, and I do have some screenshot about the memory stuff. So great question. Let's talk about the JIT and the sort of hot path caching scenarios, right? And yeah, so again, this image here, kind of again, important one, right? On the trade-off side, the startup memory footprint, I think is fairly clear. And again, I'll show you, it's day and night difference, right? Again, you're building natively, there is no JVM. So the whole thing is, much faster, footprint is much smaller, right? Now let's talk about the latency. And yes, right, it is like the JVM based images. You are after a certain point, you are going to see better throughput out of those, right? And that's precisely because of the caching and optimization that JIT and JVM does during the runtime, right? Now, if I understand it right, it's actively being worked on, right? So those are the basically arrow that indicates, like I think there is definitely investments from Oracle, who are sort of building the GraalVM, and then Spring team is working together with them to make sure they utilize all of those. So yeah, that one is JVM is better at that right now, but it's moving towards that, and so that was a perfect catch. And then I think I alluded to this one, but the build time is crazy right now, right? It can take anywhere from, again, depending on how many resources you have and whatnot, but to build that project, on my machine, for a simple one, can take up to 10 seconds. For a bigger one, it can go higher, right? As against your Java regular Spring Boot, 2-3 seconds, 4 seconds, right? And that can have sort of impact on developer UX, right? If you're a developer, it's not going to work, right? Every time I change something and wait for 20 seconds. So we do have a sort of opinion on that part. So I'll come to that on the next slide. Just the last one is the maturity part, right? It's a relatively new project, again, JVM and Spring, 20 plus years, all sort of projects, all sort of things running on it. So it's gonna get better, but it's not there yet, right? But there is a lot of interest, a lot of investment, so it's moving there real fast, right? So Spring, we are hoping to have beta during the Spring Boot 3, right? Or sorry, it's ready for production in Spring Boot 3, but we'll talk about timeline there. But that is something to think about, right? Maturity, build time performance, and throughput, it's increasing. But if you have, right, like these two, again, I have seen situations where, these two just triumphs most of these things, then, this is a perfect solution. So real quick, let's talk about sort of how we think, or how I think it can be leveraged, right? Especially on the point of higher compile times, right? So at least the idea here is, let's not change any developer UX, right? Use your IDE, use everything as is, build your Spring Boot apps, run it as you every day would do, right? Commit your code, run unit tests, faster, much faster inner loop sort of it, right? Once you're happy, right, and leverage your sort of CI pipeline to build the native images, right? And I guess the assumption there is, it's okay if it takes 10 seconds, 15 seconds to build the image and move it into your registry. It's not going to affect sort of developer workflow, right? And then that can be deployed to your dev test environments, and so testing and everything can happen on the native images. But the developer workflow, keep it as you do in a regular one, right? And that's possible with Spring Boot. And again, the idea is you shouldn't have to make any changes as a developer to sort of use this, right? Like use this native image feature. Just one thing I noticed, right? As a developer, I don't have anything in this, right? Like native images is not solving anything for me. The benefits are on the operations side, right? Like we are, saving money. These are starting much faster. So there are, absolute benefits on ops and, essentially the business side of things. But as a developer, don't take away my, Spring Boot starters, right? Like don't take away my different things that I'm used to. I'm very performant on those. I can get started on start.spring.io and build this REST services real quick. If we start adding things there, then we got a problem, right? And that's exactly what the Spring team is thinking about it. So no changes to developer UX. Use it as you would do. Just use this image building stuff in a CI pipeline of yours. And again, it's open world. Here it's mostly showing, build service and Tanzu stuff, but doesn't matter, right? You can use whatever there. Yeah, so this is again comparing, some thoughts about when you should consider using native images, startup time, memory optimization, and if you have a bigger projects, startup is not that big of an issue. Stick with JVMs. Regardless, it's still in alpha, right? So right now it's experimental, but it's getting there real fast. So I'll take a pause there. I think next one I have a demo, but any thoughts, any questions so far? Yeah. All right, so let me, again, it's a very simple demo. Like I said, I want to keep the whole thing fairly straightforward today, given that it's already almost 7 p.m. But what I have here is, two projects. You can see my ID, right? Yeah?
Yep.
Okay, cool. So this is I went to start.spring.io, right? I downloaded, created a project. This is the demo JVM project. There is one controller. You can say, hello, RVA, right? Whatever. And, nothing there, right? This is a couple of dependencies. You got your actuator here. You got your web stuff, right? So as simple as vanilla as it gets, we can build this. So what I'm going to show you is pretty awesome. I don't know if you already know about this, but I believe Spring Boot 2.2 or 2.1 onwards, this build image thing goal is already included, right? And what that lets you do is build Docker images without having to craft your Docker files, right? So I don't have Docker file in this project, right? It's just the plain old Spring Boot app. But because of this build image goal, I'm able to sort of build Docker image, right? You can, just like you build jar file, in this case, it's going to build me a Docker image, right? And it will have the base OS, all the Spring Boot optimizations, layers, what have you. And that's I guess talk for another session, but it uses technology called build packs, or cloud native build packs to be more precise. It's pretty awesome. It's a CNCF project, fully open source, but I love that thing. So as you can see, it just spit out the Docker file, right? So you have your JVM demo JVM file here. So I have Docker running locally. So if I do Docker images, and let's do, let's grep on this demo JVM. What you will see is this is my demo JVM image, and with this minimal dependencies, this is about 260 MB size, right? I can run this, right? Again, I'm showing it in a Docker because I'm going to show the native image running as a Docker container, right? And that's where the sort of performance comparison comes in. So I'm just running this on my local Docker here, right? So you have your Docker JVM image. I'm mapping 8080 port to the images 8080 port, so nothing fancy there. So let's run this. And what you will, again, this is your standard Spring Boot. And since I have, I guess, a bunch of things running, the startup time is about 6 seconds, right? Fairly standard stuff here. So we can hit just to show you that it's actually running. We can. Yeah, so you have your sample output, hello RVA, right? Cool. So let me stop this, right? And let's go to the more fun one, which is this, right? This is the basically demo for native images. Again, pretty much same thing here. You have your standard Spring Boot app, no changes here. Same hello controller, hello RVA from native image, right? Again, map to the base path. And then you have the POM file, right? And there are certain changes here, right? So the first thing, after downloading from start.spring.io, and this will probably go away as it becomes part of Spring Boot 3.0, but right now it's a sort of experimental project, so you have to add a couple of things. The first thing we are adding is the dependency for GraalVM native library, right? And this is all well documented, so there's not much there. But we are adding 8.0.8.5 version of Graal native image. Dependency. And then the second thing we are doing is a little bit of configuration for the build packs. First one, we are using the tiny OS. Again, that's your base operating system. Remember, we don't even need a full-blown Ubuntu or anything like that, right? It's sort of minimal operating system that you can get. Ops people love it, security folks love it, right? Like there is nothing there on that image. Then you have this flag currently, since again, you have to enable this, right? So the build time, boot native image flag turned to true. And then there are 3 optimization. I briefly mentioned those. Hey, for this project, I don't need YAML support. I don't need spell. I don't need XML, right? So, just remove those. And that is going to affect the sort of image size, so to speak. I'm just telling my project, I don't need that. And that's it, right? Like that's, and you have to add milestone repos, right? This is not in a main one yet. So yeah, that's the only change, right? So let's build this. And again, same goal, Spring Boot build image, right? And you are going to see sort of considerable difference here, right? The image build, this is where the build time comes in. It's going to analyze all those things, build the jar file, analyze it, build the thing, native image. So it's going to take longer. 10 seconds, 12 seconds, again, depends on resources on my machine here, right? There are some caching going on. So the first time is it takes longer. Subsequent times, there are some caching stuff that goes on, so it doesn't seem like it's taking that often, but it's still a noticeable difference. And again, that's one of the things that you have to consider, right? Like, why not just go all in on native? It's going to take some time on the build. Yeah, so let's give it a few seconds to see.
While that works, what was that HTTP command you used earlier?
Yeah, it's pretty cool, utility. It's called HTTP PI. Essentially, it's a command line utility. You can hit your endpoints, and it's like curl, right? But it's a, I guess, nicer UX, right? Since I'm just hitting localhost, don't need to put that. The headers and footers, there is more color coding and whatnot. But yeah, it's called HTTP PI, so HTTPIE.
You just linked it in the chat.
Yeah.
Cool.
Oh, you have it? Okay, perfect. Yeah, it's cool. I started to use it more and more. Again, if you are doing more of RESTful APIs and whatnot, it comes in handy.
Yeah.
There are browser extensions, but still. One thing one place I found it really helpful, curl and even HTTP PI, is, if you have to, basically update your host IP, right? So let's say you have a domain, right, and you want to just test it. Now, either you go to your host entries and add domain and your private IP, and then clean your cache and then run it and to test either your certs and whatnot. Curl and HTTP PI provides a little flag which you can say, hey, just if you try to go to this domain, forward it to this IP. So essentially, it saves you trouble of updating your local sort of etc host or your host file to test things locally. And one thing I recently came across, like, yeah, that's a useful feature there. Of course, curl has so many things. I think HTTP PI does too, but yeah.
Cool. Thanks for that quick rundown.
Cool. Yeah, absolutely. There are interesting things happening here. Again, let me just walk you at least some of those. So there is first one, right? Like, this is all build packs. So, jar file is built here, right? So the jar is ready. You run your test. Things are as usual until this point. From that point onwards, we are basically using build packs. Now, Paketo build packs, again, open source projects which implements the cloud native build pack specifications, but it has the Java build packs and all sort of different languages, but there are different phases, right? So the first phase is detecting. So you're essentially throwing a code at it, right, and telling it, hey, build image for me. So the first thing it needs to understand is what kind of code is it, right? Is it a Java code, Ruby code, Node.js, Python, what have you? And that's what the detecting does, right? So you see there are a bunch of build packs which are identified as the relevant one, right? Graal, Spring Boot, Spring Native, right? So those are the ones going to contribute to building the image. There is some analysis thing. I believe there is some Graal specific and whatnot. And then the actual building starts, right? So essentially, you set some optimization, set some parameters, right? Like JVM use 11, tooling options. There are actually a lot of optimization that the Spring Boot team does for the build pack. So again, that happens, and what essentially end of it is you get the image, right, without you doing any of that work. And this is Graal specific stuff happening here. So it's still building, it's still going on. I promise next time, if you don't make a whole lot of changes, it'll be faster. But that's one thing you have to be careful, right? Like it is going to be a time-consuming thing. Right?
I've got a question.
Mm-hmm.
So on a previous slide, you mentioned that like a good hybrid solution is to have the regular flow on your local, and then in the pipeline you run with Spring Native.
Yeah.
So if it's going to take a long build time for the first time, it's always going to be the first time when you're running, like running Jenkins or whatever your CI is. Technically it's the first time every time from a PR build or kicking off the main.
Yeah.
Right?
Yeah.
It's always going to take this long.
Yeah, and so what I'm proposing here is, right, delay that, right? That build time is going to improve, but right now, essentially delay that to the CI phase, right? So in your sort of local UX, right, as a developer, you have your machine, you're running, you're in a code, right? You're doing your unit test. Don't build native images here, right? Use your Spring Boot tooling, right? Developer extension, what have you. That way, there are no changes here. Once you are happy with your ticket or happy with your feature, when you push it, let the CI, the machines build it for you, where you are not as sort of compressed for time, right? Like it's okay if it takes 10, 15 seconds or 30 seconds, right? Because you are not blocked by that, right? And once the deployment happens, either QA team or whatever can now start testing. So again, there are a bunch of assumptions, right? We are assuming you have fully automated, at least on the developer, the CI side, right, where you are, Jenkins or what have you, which can build images for you in an automated fashion, right? And that delay is okay. So those are the essentially assumptions, right? Like, hey, delay it till the CI part. Yeah.
Okay.
That makes sense, or
no, it makes sense. But I was just I think the it's not really a concern, but just something to touch on.
Yeah.
I mean, when I do kick off a build on Jenkins, I don't look at it until I get an email saying, "Oh, it failed." So I'll go doing something else in the meantime.
Yeah.
But so with this, even though this is a minor change that we've made from the first way you did it to the second way of building, if there's more complex stuff that's going on under the hood, is that going to add more time for building on the pipeline? Or is it negligible versus like, a minor change?
I want to say that it is the time. I don't think it will affect it's already taking 7 minutes, right? For the first one.
Yeah.
I don't think the complexity there will affect. What is affecting is like it's doing all those things that JIT and JVM does at the runtime, right? Like analyzing all the paths, right? Like all the reflection stuff, everything that happens during the runtime is now doing it during the compile time, right? So it can be as optimized as possible. So the majority of time is going in the whole framework and JVM optimization, all that. So I haven't tested it on the bigger projects, so it might still be still affect the time, but my guess is like if it is already taking 7 minutes with 2 lines of code, it's not going to be as much bigger than that.
Okay.
But yeah, we do have our image built finally. Again, this depends on a lot of things, right? Like how much RAM, how much CPU my local machine has, right? If you're building on a CI which has a beefier machine, it's going to be fast, right? It's essentially the CPU time or CPU cycles you have available. But yeah, so let's do the same thing here, right? So if I do Docker, now that the image is here, right? So the image name is Docker native, demo native. So if I do Docker images, right? and I want to do this thing, right? So I'm gripping it on, so filtering it on JVM. That's the image we built earlier, and then the demo native, so the build image we just built. And right away, what you see is the size, right? So you see that earlier image was 260 MB. We got it down to 93 MB, right? So that's the first thing. Next is let's look at the the runtime, and again that's where it shines. So hopefully we can see what is the difference here, right? So demo native, and I run this, and it starts in 200 milliseconds, right? The same project, same everything was taking about 6 seconds on my machine to start up. Here it's 200, right? So that's the sort of biggest advantage, right? Your startup time, smaller images, and again, it's going to run on much smaller footprint VM, right? Like our containers. So you are going to save some time there. So let's make sure it works as expected, right? So if I do my HTTP thing, it responds. So everything works as expected. It's just that it's it's a natively running code, right, on your container, and it starts really fast, 200 milliseconds. So that's pretty awesome. And without making any changes to the code itself, right? So the config changes are going to go away once it becomes sort of a part of the Spring Boot 3. Yeah, so like I said, I want to keep the demo fairly light. I do want to show you some things that we profiled sort of beforehand. So let me go to the presentation mode and show that, and then we can sort of wrap up. All right. So real quick, right? You are using Spring at this point. It's 4.3 or 2.4.3, or 4.2 is fine. Works with Java 8 and 11. That's fine. But this slide is where the basically config changes that you have to do, since this is still an experimental project, right? So you're adding Graal native dependency, and then you are adding couple of build pack related flags, right? Enable the native image, and then the optimizations. Yeah, we talked about build pack, so I'll skip on that one. So yeah, Greg, you mentioned the whole size thing, right? This is basically what we profiled it. So what you're looking at is an output of this tool called Dive, which essentially lets you see what is going on inside your image, right? Inside your Docker image. So in this case, you have your traditional app, you have the base layer, right, of 63 MB of your sort of OS, right? The next one you got is your jar files, right, your executables. Then you got your JRE. You have your Spring Boot jars, right? That is, so essentially, if you look at on the left hand side here, that's each layer is adding some meat onto it, right? So the image size is growing as we go. This is finally your class, right? So if I go back for 1 second, the total size, it comes to whatever we saw, 260, 270. Again, it increases as you add the libraries and whatnot. So in the sort of native side of things, you still have the base layer, but then you have very little things, right? You have the sort of launchers, and then your code, right? Like this is your and this was done for the command line runner, so this is not a web app, but you get the idea, right? Like you're basically removing all the sort of middle layers, and then that's why size is as smaller as we saw. So these are the numbers that Spring team ran, right? And to compare, right? Like if you heard of Spring Boot Pet Clinic app, which is kind of a kitchen sink app for Spring team, like it uses a lot of the starter apps, and it's fairly feature rich, right? Just to sort of make sure we are covering from the demo perspective all the features that Spring teams usually use. So, it's a decent size app, so to speak. It's not the hello world of things. So in that case, build time was increased, right? As 800% in this case. Image size was almost half, right? And there are benefits to that, right? You're storing this, you're moving these images place to place. So, it matters, right? Like it saves time. It's less things from the security perspective. So that's good benefit. But the last two are the main ones, right? Like you saw that from 2 or 2.8 millisecond or 2.8 seconds to 100 millisecond, almost 100% or 96% reduction in startup time. Again, that's huge if you want to build something in a container or serverless world where you want to have scale to zero kind of features. And then the memory thing, where again it's running natively in OJVM. All the JIT things are gone, right? And so it can run. It's 187% improvement, about 100 MB size for RSS. So same is for the CLR. It's a basically command line runner, right? So and we have the samples here. Is my colleague built and ran this. So these are open source repos. So you can feel free to check it out. So yeah, any thoughts, questions on this one? I'm almost done. This was kind of a last one. Yeah, I just have a few roadmap items to share. Yeah, so right now it's in experimental alpha stage. 8.5, 0.8.5 is out. End of Q1 is what I'm thinking. So maybe March there will be 0.9. The team, I think, is going to tag it as a beta. So fairly stable. The goal right now is get as basically support all the starters that you see on start.spring.io, right? So I believe there are 20-ish already supported, fully supported, right? So they are just adding those, right? So getting it as feature rich as possible. And then Spring Boot version 3 native will be sort of part of that, right? So none of the experimental stuff, right? It will be just in there. And like I said, the goal that I heard from the team and again publicly is the goal is to keep your Spring Boot apps unchanged, right? And just be able to build these native images without you having to install Graal or make any changes, add configs, none of that, right? Like it's building that behind the scene, so you don't have to, right? And that's the sort of goal of this project here. Yeah, we talked about that. So Spring Boot 3 is when it will be sort of first class support for Spring Native. Yeah, that's it, right? Again, I'm pumped. I saw those numbers first time when during I think Spring 1 they had a session, and I was like, yeah, that's amazing, right? Especially as a Java developers, when folks were like, hey, you should build that in Go. I was like, no, I don't want to build and learn new language and ecosystem just so there are they have point, right? Like those images are smaller, faster. So this sort of gives Java developers a good sort of way to use the maturity of Java ecosystem, but still leverage the benefits of cloud native and container ecosystem. So yeah, Spring Boot 3 it should be in there, and yeah, Spring is still the most productive framework out there. I'll share this one, especially it has a bunch of links, but everything is open source. So under Spring GitHub repo, there is experimental repos, and that's where it is currently. There are a bunch of sample apps. There is a pretty good actually documentation for alpha stage, so there is no problems there. And then this video, if you are excited, definitely watch this one. This is the Spring Native team lead Sebastian talking about Spring Native project during Spring 1. So he goes into all sort of details of, Graal and how, how we build the sort of map of your dependencies behind the scene and, what's going on behind the scene. Again, all you as a developer doing is, build image, right? But there are a bunch of stuff happening behind the scenes. So it's a good one to sort of, if you are interested, to check it out. But yeah, that covers it. That's my presentation and demo. Happy to answer any questions you might have right now.
I guess I had that one about the memory and where it's getting that huge boost in how much free memory there is. And I guess if it's all just the JIT compiled classes aren't being used, then I get that. Or is there somewhere else?
I think the fact that it is building the native program, right, to run, right? So it's, again, Go, or think of it like your bash script, right? Running natively without any interpolation, interpretation layer, or any of that, right? JVM, JIT, none of that, right? It's just essentially you're building this for the target platform of your, Ubuntu base OS, or, OS X, or what have you, right? And again, I'm light on that stuff, but my understanding is when you do that, it's basically, it's natively running, right? You don't have to start up JIT or JVM or then, compile thing and the memory part. So, it's again, doing RSS stuff on your own, right? Like you can do it, right? But I didn't spend as much time on that. But yeah, just to compare from the Go perspective, like if you look at any Go image on Docker Hub, these are small images, tiny ones, right? And they don't need like JVM like memory to run. And I believe that's because JVM is doing all sort of optimizations for you, so it will just take it as much whatever you give it, and then sort of use it how it sees fit, right? Not the OS, right? So it just grabs it from OS. I guess I'm out of my depth here, but that's my understanding, anyways.
So it doesn't have the traditional Java garbage collection anymore. It's handling it, I guess, like C and Pascal and all the old ways we used to do things. Is handling it now if it's gone native.
So let me, I guess, caveat that it does have that, right? Like you still have garbage collection, you still have thread management. They do some interesting things there. They call it a Substrate Vm. That's the GraalVM team's term. And that is a sort of much lighter weight package, right? It's not JVM, but you still have the sort of memory management, thread stuff in there, right? And they call it a Substrate VM. So, check it out. So yeah, you still have some of that, right? So it's still doing garbage collection and things like that.
Okay, cool.
Yeah.
Any other questions?
Oh, but that was a good talk. Thank you.
I have a quick question. When is it coming out approximately?
Yeah, so the beta should be out in a month, like maybe end of February or early March. That would be 0.9 version. But the production one will be in Spring Boot 3.0. And if I understand, I don't think Spring Team has sort of committed to the timeline of the sort of Spring Boot 3.0, but I think it'll be ready by end of year. And again, I don't have a full visibility on that part, but the beta should be coming out pretty soon.
I just wanted to say thanks. This was really awesome. You've given me some stuff to mess around with this weekend and experiment with it. So that's awesome. Thanks again.
Cool. Yeah. I mean, again, like I said, I'm not on the team, but I was just excited to tinker around these things. So that was my goal, right? Hoping I give you enough pointers, so you can try it out on your project, see if it helps you. But cool. Glad to hear.
Yeah, I'm just gonna echo what everyone is saying. It's a very good presentation. Super cool that you came out and talk about this for us.
Awesome. Yeah. Thank you. Thank you for having me.
Oh, go ahead, Greg.
I was gonna leave.
Okay.
Instead of just doing the Irish goodbye, I said goodbye like the real.
Well, if there's no other questions, thanks everyone for joining us. I'll have the link posted up online shortly. And let me stop recording.